Hello, this is Professor Keene. In my previous lecture, I provided an introduction and some biographical notes on Ptolemy, the writer of perhaps the most famous astronomy textbook ever written, titled the Almagest. In this lecture, what I'd like to do is begin into his preface, or his chapter 1 of the Almagest. This is shown or included in chapter 5 of A Student's Guide Through the Great Physics Text, volume 1, beginning on page 42. In this preface, what Ptolemy is mostly interested in doing is showing how astronomy as a discipline fits into other areas or fields of knowledge. So the first thing that he does is he divides the study of philosophy into two branches, what he calls practical and theoretical philosophy. Here what he's really doing is he's using the exact same classification that Aristotle had done a few hundred years before him. So he's very well versed in Aristotelian thinking. In book 1 of Aristotle's Metaphysics, he divides the study of philosophy into practical and theoretical. By the way, what do we mean by metaphysics? After all, Aristotle's book, we didn't study this particularly, but maybe I should give you some background comments on this. What is the study of metaphysics? Metaphysics is a branch of philosophy that deals not so much with how we should act, that would be the study of ethics, or how things appear to us, that would be the study of physics, but rather what are the underlying causes or principles that govern nature and the world, the things we see around us. So what are the first principles that we have to take for granted even to study philosophy? That's the study of metaphysics. So Aristotle wrote a book called Metaphysics, and in this book, in book 1 of his Metaphysics, he divides philosophy into two branches, practical knowledge and theoretical knowledge. So what do we mean by practical knowledge as opposed to theoretical knowledge? Well, practical knowledge, roughly speaking, is the study of how we do things or how to do things, whereas theoretical knowledge is a deeper understanding of why things work the way they do. So maybe a couple of examples would help. When you want to study a language, let's suppose you're trying to study German or Spanish or some other language, there's a couple of ways of approaching this. One would be how you teach a child language. You simply speak words to them, they memorize them, and they just listen to you and they mimic you. And that would be sort of a practical way of learning a language. The child isn't really having a deep understanding of the structure of the language or why it works the way it does, merely they're observing the parent, listening and repeating and mimicking that. That would be kind of a practical approach to the study of this language. As opposed to a theoretical approach to studying the language, that's probably what you do when you're in 7th, 8th grade, where you start diagramming sentences, understanding the structure of language. Maybe you saw that as more dry, perhaps less practical, but in so doing, you really started to understand why the language works the way it does, and the structure of it, and how it's similar or different than other languages. Similarly, we could take another field of knowledge, for instance, like metalworking. So one can learn how to do metalworking without understanding why it works in the way it does. That would be a practical approach to metalworking. You can watch a master welder or a master jeweler and simply mimic what they're doing in order to be able to join different kinds of materials, or in order to shape them or stamp them or work with them in the way that you do. It's more experiential kind of knowledge. Whereas a theoretical approach to it, you might ask questions like, why does silver melt at a certain temperature that is different than copper? And then you're approaching from a theoretical perspective, trying to ask questions of why things work the way that they do. And really, in order to teach a subject in a coherent way, you really need to have a theoretical understanding of that subject. So that kind of gives you an example of this breakdown of knowledge into practical knowledge versus theoretical knowledge. And that is essentially what Ptolemy is doing here. He's laying out this distinction, okay? And by the way, astronomy is going to fall into, as he says, theoretical knowledge. We'll get to that in a moment, okay? Now, practical knowledge, as Ptolemy mentions at the bottom of, I guess, the second paragraph on page 42, theoretical knowledge can be broken into 3 different categories. And the first of these categories, he says, is the study of theology. Now, you may or may not like how he's breaking this theoretical knowledge into these three categories, but just kind of play along for a little while, see where he's going, and then you can decide whether you agree with it or disagree with it. So theoretical knowledge can be broken into three categories. He calls them theology, physics, and mathematics. And so I want to make a few comments about each of those. So theology, as he says, deals with first causes or ultimate causes of all existence and all change in the world. So if you want to know what is the prime mover or the ultimate cause of why the world is the way it is, you're asking theological kinds of questions, and that quickly leads to the notion of God or gods. Ptolemy himself is not a Christian. I'm not sure what his theological commitments are, but he speaks of God or gods as the study of theology. He mentions also that the study of theology, the object of that study is completely separated from all of our sensory experience. So you cannot see or touch or feel God. He's invisible, undetectable by our senses, but not by our reason. So by our reason, we can arrive at some understanding of God or the gods. Okay. So I guess what you might want to do is to think about whether or not Ptolemy's perspective on theology coheres with a Christian understanding of theology. I guess in a sense, from a Christian perspective, theology deals not with the abstract properties of God, but how God came down to earth in the person of Jesus Christ in a tangible, sensible kind of way. So a Christian might disagree with some aspect of how he understands theology, but on the other hand, the Christian might agree with some aspects of how Ptolemy's understanding theology. After all, God the Father is not immediately accessible to our senses, although the incarnation means that his Son is accessible to our senses. Okay. The second branch of theoretical knowledge, as Ptolemy mentions, is a study of physics. And this, he says, is a study of the material and ever-changing qualities of corruptible things around us that we see here in the sublunary region. Remember, the sublunary region is the region below the moon. So everything we see around us here on Earth, when you study it, when you study how they change, the colors, the tastes of things, the temperature, how hot or cold it is, that is a study of physics. So notice that his understanding of physics is a much broader understanding than what we today call physics in a college setting. We separate physics from biology, from chemistry, from psychology, and so on. But all of that would really fall under the branch of what he would call physics, or the study of nature in the broad sense. And again, it focuses on ever-changing, unstable, uncertain kind of properties that are in flux all the time. That's a study of physics. And then, if you look at the next page, on page 43, I guess what I've been talking about he goes from the bottom of page 42 to the top of page 43, where he's discussing physics. And then he talks about mathematics, which he says is the study of forms or motions, which we can access via studying things like shapes and numbers and sizes and kind of quantifiable sorts of things. And these can be considered either with or without matter itself. So for example, I can study mathematics by counting the number of apples that I see. Maybe there are 7 apples. But I can consider also the number 7 apart from any material, tangible kind of objects. So mathematics both applies to material objects, but it also can be considered in the abstract. So I can talk, as another example, you can talk about triangles in the context of the shape of a pyramid. But on the other hand, you can talk about the abstract properties of triangles. The sum of the internal angles add up to 180 degrees. They have 3 vertices and 3 sides and so on, without ever referring to material objects. So in this sense, the study of mathematics is kind of a bridge that lies midway between theology, he says, and physics. And it alone, as he says, provides firm and credible knowledge. He says this because he says theology is a study of things that we cannot see. It's more speculative. And Physics is the study of changing, mutable sorts of things, whereas mathematics, he says, is a study that provides firm and credible knowledge. You may or may not agree with this. This is Ptolemy's perspective. And he mentions that mathematics can be used to understand both the changing things that are here on Earth and also the unchanging things that are in the heavens. Let me be clear about where he's going with this. So we can use mathematics to study things like the motion of a baseball. We can describe its speed in terms of numbers and mathematics. But we can also use mathematics to study the things that are in the heavens, like the planets, the stars, and so on. Things in, he would say, the unchanging region of the heavens. And so he says mathematics sort of lies between theology and physics, and it can provide insight, he says, into both of them. It can provide insight into physics because, like I said, it can be used to describe and provide insight into motion of visible moving bodies, linear and circular paths, for example. And he says it can provide insight into theology because the order and harmony, particularly of astronomy, can direct our minds toward the first cause of all things. And he says it can prepare clear-sighted, and this is on page 43, he says a study of mathematics can prepare clear-sighted men for goodness in actions and disposition because of the uniformity and the orderliness and the symmetry and the calm which the divine things that one's studying have. And it can also, he says, make those who follow or study mathematics lovers of divine beauty. And he says it puts the soul in a similar kind of position. Now I'm curious what your reaction to this is. If you think that mathematics can kind of give your soul rest. I don't know, maybe it stresses you out, but he says the study of mathematics actually has a moral implication for your soul, that it somehow shapes your soul to make it more orderly and harmonious. Now, again, you might be uncomfortable with this, but let me put it in a little bit of perspective. Perhaps some of you are athletes. Perhaps some of you play baseball or football or ice skating or something like that. And oftentimes, coaches and others will say, well, when you become an athlete and you do a sport on a team, there are certain kinds of moral lessons or ethical lessons that you learn, and it gives you certain virtues. It teaches you courage. It teaches you teamwork. It teaches you perseverance and other kinds of virtues. This is kind of a commonplace. You hear these kind of things about the benefit of studying sports or being involved in sports. Well, really what Ptolemy is doing is saying the same kind of thing here. So I'll ask you this. The kind of things we attribute to doing a sport, can we also say that about studying certain subjects? So for example, by studying music, what effect does that have on, what virtues does that instill in you? What about the study of astronomy? That's essentially what Ptolemy is saying here, is by studying astronomy, it has a certain impact, not just on you kind of making you work, but it has an impact on your soul, on your person, on your character. It imprints you in a certain way. This is what Ptolemy is saying. Okay, now Ptolemy in what follows is going to present his theory of the heavens as briefly as possible. And so here what he's provided is a preface or an introduction to the study of astronomy, and in the following chapters he is going to then present his theory of astronomy. So before we go into that, let's just look at his chapter 2 on page 44, where he gives a brief outline of where he's going with all of this. In chapter 2, he says, first of all, we're going to look at the celestial sphere and its appearances from different latitudes. So think about the celestial sphere as a sphere on which the stars are riding as it's rotating around the Earth, which is at the center. And how do these stars appear from different latitudes on the Earth? Secondly, he's going to talk about his theory of the sun and the moon, the motions of the sun and the moon. Third, he's going to talk about the motion of the stars and particularly the motion of the planets. And he says he's going to refer to both ancient and modern observations. Particularly, he's going to be paying attention to the ancient writings of the Babylonians and the Egyptians and the ancient Greeks. And he also mentions that he is going to rely heavily upon geometrical methods. In this course, we're not going to push the geometrical methods very hard. This is an introduction to astronomy course, but if you're interested in this kind of thing and how he uses geometry, it's a wonderful read to try to push through some of his geometrical proofs. Why don't we stop there? Next time we'll talk about chapter 3.